Hi, welcome. And in this video, we are going to discuss how to test statistical hypotheses based on a single sample data using t-statistic. To be more precise, we are going to perform two-tailed t-student test. So please consider the following problem. 25 students play a game, their average score is 103 and the standard deviation is equal to 12.1. We will assume the value of alpha equal to 0.1 and we are going to verify whether the average score is equal to 100 points. To be more precise, we are going to formulate the following null and alternative hypothesis. So the null hypothesis will state that x bar, average score, is equal to mu0, the reference value for comparison. In our case, it's 100. And the alternative hypothesis states that the average score is not equal to mu0. Please keep in mind that here we are going to analyze both sides of the distribution, because whether the score is bigger than 100 or whether it's lower than 100, both of those will be sufficient conditions for rejecting the null hypothesis. So that's why each time we perform two-tailed test, we have to select the critical value of t corresponding to alpha over 2. So here we assume alpha is equal to 0.1, and when we go and check the table, we are going to select alpha equal to 0.05. So we've got 25 students, which means there are 24 degrees of freedom. You should remember that the number of degrees of freedom is equal to the number of observations minus 1, in this particular case at least. So we check the table for alpha of 0.05 and 24 degrees of freedom. The corresponding critical value is 1.711. It's always useful to analyze the rejection region or rejection regions in case of two-tailed test. So here we are. So this is familiar t-distribution for you. And we know that we will be able to reject the null hypothesis if the corresponding t-statistic we are going to compute in a second is bigger than the critical value or smaller than the critical value. So everything to the right from 1.711 and everything to the left from negative 1.711 is characterized as rejection region. And the next step is to compute t-statistic. We already discussed how it might be computed, but nevertheless, this is the formula. So we have to subtract our reference value for comparison, or the hypothetical value of the sample mean from the actual sample mean, and we have to divide this value by the ratio of sample standard deviation and the square root of n. So here we are. The sample mean is 103. We want to check whether it's different from 100. The standard deviation is 12.1 and there are 25 observations, and the resulting t-statistic is equal to 1.24. So now we can go back to t-distribution, and as you can see, 1.24 does not go within any of two rejection regions, which means that we cannot provide sufficient evidence for rejecting the null hypothesis, and basically we cannot reject it. Again, we already discussed this, but I want to reinforce that it's not correct to say that you accept the null hypothesis, because this is something related to type 2 error, and probability beta associated with type 2 error is unknown. So that's why we simply fail to reject the null hypothesis. So that was it when it comes to two-tailed test. In the next video, we are going to discuss one-tailed t-student test, And thank you for watching.